Hello guys, and welcome back to my channel. So today we're working on formation of differential equation. That is just basically how you can form differential equation. And when you are given any equation, a linear equation, a non-linear equation, how can you change it to a differential equation? That's just it. So the first thing you need to note is that the number of constants determines the number of time you will differentiate. Let's say, for example, you have been given an equation. You have to look at the number of constants you have there. If you have 3 constants, when I say constant, it means all these A, B, it could be any number. A can take any number, B can take any number. So C1, C2 is also a constant. A, B is also a constant. So the number of constants you have determines the number of times they are going to differentiate. So you can keep that. So solution to this formation of differential equation, actually we have shortcuts, which are tricks. Then I will not be treating that now. If you want to get that video, you can subscribe and then turn on your notification bell so that when I upload the video, you'll be able to get it. You'll get notified immediately. So today I'll be solving the normal solutions to these equations. Formation of differential equation. I'll be forming differential equation from these equations. Then the next video, this same equation, I'll be explaining all these short tricks. So look at what I said here. So when you have this equation, you must have something like this as your final answer, and this is just the short trick to getting it. Similarly, here too, you must definitely have the same answer as our final solution or final differential equation. Here too, you must have the same equation as the final differential equation. So if you don't have this, so whatsoever, this tricks is helping you to, let's say if you are doing a CBT exam, you can just use these short tricks. But then if it is written, it makes you know what you are doing, so you'll be sure if your solution is correct or wrong. So for the first question, we have y equals ax plus b. Now recall I said if you have the number of constants you have determines the number of times you are going to differentiate. So how many constants do I have here? I have 2 constants, right? So that means I have to differentiate twice. So looking at this, if I differentiate this, I have ax plus b. That means I'm going to be using product rule to differentiate. And then there's also a short trick to product rule. So look at this now. I have y equals ax plus b. Now this here, I'll have to use product rule to do it. So the rule is, the shortcut is, I differentiate 1, I leave 1, or let's do this instead. I have ax, so I bring this line down, If I differentiate a with respect to x, that means a is a constant. That means I'm differentiating with respect to x. This is not x, this is a, so it's a constant. When I'm differentiating any constant, it should give you what? 0. So here will be 0 automatically. Now if I differentiate x with respect to x, that means I will have 1, because differentiating, it means the power, you bring down the power, this is 1, write your question back, then you use the power by 1. So this is 1 x raised to power 0, and anything raised to power 0 is what? 1. So I'll have 1 here. That's why I have 1. Then you cross multiply. That means when I differentiate this, I should have 1 times a is a, 0 times x is 0. So when I differentiate this, I should have y equals a. Now similarly, if I differentiate b, what will I have? 0, because b is a constant. That is why here I have y prime. And you should take note that when you have y prime, it's the same thing as this y dx. If I have y prime, same thing as this squared y dx squared. So that's why I have y prime, just to make our notes neat and easy to solve. So I have y prime equals a plus 0. Now don't forget, you differentiated just once, but then you have to differentiate twice. Second differentiation, differentiate a constant with respect to x, you have what? 0. That's why we have the squared y dx squared equals 0. This is the final differential equation of this normal equation you have here. Now we just formed a differential equation from this equation. You can check, apart from the shortcut, you can also check if you are correct. That means you can go back. Looking at this, I have the squared y dx squared equals 0. If I'm to integrate this, If I integrate y prime prime to the squared y dx squared, I'll have y prime to reduce now. If I have this, if I have y prime prime, if I integrate it, I'll have y prime. If I integrate y prime, I should have y. So keep on reducing, opposite of differentiation. So if I integrate y prime prime, I'll have y prime plus c, that's your constant, equals 0. Now I integrate again because I'm looking for a normal equation, not a differential equation. So if I integrate again, I'll have, if I integrate y prime, I'll have y plus, if I integrate a constant, I can take it out, I'll just have c1x. Just like if I'm integrating 1 dx, for example. So this will just be x plus c, something like this. So now if I'm having c, I can just bring my c out. I'll just have c1x. Then, you know, after integrating, you should introduce another constant. That's why I have plus c2 here, equals 0. Equals 0. So this is the same thing as taking this to the other side. I'll have y equals minus c1x minus c2x, which is the same thing as this y, because this your c1 is a constant. It means you can have negative value. Your c1 can be minus 5, can be minus 2, your c2 can be minus 1. So this is the same thing as this if you are dealing with constant. So it's not the same thing with the question that has been given to you. Automatically it's the same. So you can go backwards to check if you are correct or not. Go to the next question. We have y equals c1 e raised to power x plus c2 e raised to power minus x. And don't forget, I said using the shortcut which I'm here to solve, or which I'm here to explain, and I'm going to do that in the next video. So you have to subscribe and turn on the notification bell to get notified when I upload the video. This next question, this is a shortcut, and you must get y prime prime minus y equals 0. This is the final solution, the correct solution. So after doing all your solution, and then you don't get this, then you should know you have a problem somewhere. So here I have two constants, I have to differentiate twice. So just like I said, product rule, right? I would differentiate this. So if I differentiate this, this is c1 e raised to power x plus c2 e raised to power minus x. So I have y equals c1 e raised to power x plus c2 e raised to power minus x. Now this is c1 e raised to power x, right? Arrow, arrow. If I differentiate c1 is a constant, I have 0. If I differentiate e raised to power x, I still have e raised to power x back. Then I cross multiply. If I cross multiply, I have c1 e raised to power x plus 0 e raised to power x. Anything multiplied by 0 will give out what? 0. So I have c1 e raised to power x for the first one. Similarly, the second one, I'll do the same thing. I'll have c2 e raised to power minus x. I bring down the arrow, Differentiate c2, I have 0. Differentiate e raised to power minus x. The reason you are having e raised to power x to be e raised to power x is because when you have e raised to power x, look at the number beside the x. Differentiate the number first. So the power of your of your exponential. So the power here is x. So if I differentiate x, so I have 1. So that's why I'll just bring 1 to the back of this, and then e raised to power x, write down the question back. So if I have e raised to power 2x, it implies I'll differentiate 2x first. If I differentiate 2x, I should have 2. So I have 2. Then write your question back, e raised to power 2x. Now I want to differentiate e raised to power minus x. If I differentiate, I'll differentiate the power first, right? So differentiate minus x, you should have minus 1. Then you write your question back, and I can cross multiply. So this is just minus c2 e raised to power minus x plus 0. So that means when I differentiate this, it means I have this and this. That's why I have y prime equals c1 e raised to power x plus minus c2 e raised to power minus 2x. Now differentiate the second time, you have differentiate this one, c1 e raised to power x. This one again, don't forget, this will be minus c2 e raised to power minus x. So minus times minus will turn to plus. So I have plus c2 e raised to power minus x. So you can just do this differentiation gently. Trust me, you get it. Now notice that I have y prime, I have y prime prime. And you can see that this c1 e raised to power x plus c2 e raised to power minus x is looking just like the question that has been given to us. So that means I can tell you that my y prime prime equals y from this equation, since this is equal to this. So y prime prime equals y. Now I can just take my y to the other side. If I take y to the other side, I should have y prime prime minus y, which is the squared y dx squared minus y equals 0, which is the same thing we got when we use the shortcut. So that's the solution to number 2. Going to the next question. We have y equals ax squared plus bx. Now we have to differentiate twice. You should also take note of something. After differentiating twice, or let's say after differentiating with respect to the number of constants you have, and then you end up not having a differential equation, then you have to gently look at what you can do. There are two ways. It's either you make those constants the subject of the equation and then equate it back to your question. Take note, you make the constant after differentiating twice, you make those constants the subject of the equation, just like making something subject of the formula, and then you take it back to the question. So now look at this. If I differentiate this one, I have y prime equals, this is the same thing as product rule. So after this one, I won't explain product rule again. So I have ax squared. So I bring this down. If I differentiate a 0, differentiate x squared, that will be 2x, then I cross multiply. So this is 2x times a, that's a 2x plus 0. Then if I'm to differentiate bx, I bring down my arrow. Now my arrow, this is 0, this is 1, then I cross multiply. So I should have b plus 0, which is b. That means my dy over dx, which is same as my y prime, equals a 2x or 2ax. Rather, 2ax is better. That's the best way to write in mathematics. So plus b, that's why I have it here. So now, differentiating the second time, I have just 2a because I'll use product rule again for this. This is one constant, this is another constant. So I have it as 2a, then x. So let your constant stay alone. Differentiate this. This should be 0, this should be 1. So I cross multiply. So I should have 2a plus 0, and that's automatically 2a. So I have y prime equals 2a. So now you notice that this isn't forming a differential equation after differentiating with respect to the number of constants we have. That implies that I'll have to make those constants stand alone and then equate it back to the equation, to the question that's been given to you. So here, if I make a the subject of the equation, I have y prime prime over 2 equals a, which is the same thing as this. So then, after doing this, you put a into equation 2. That's my a is y prime prime over 2, right? So that means anywhere I see a here, I won't just put a, I'll put y prime prime over 2. So that's why I have y prime equals the 2 here, then a is what? 1 over 2 y prime prime, then the x plus b. Now I can tell you that my y prime equals, because these two we cancel these two, and I can say my y prime equals y prime prime x plus b. Then I can say my y prime minus y prime prime x equals b. Now I already have b, I already have a. Now I can now put a and b back. I can put it back into the equation that's been given to us. So that means y equals ax squared plus bx. Then anywhere I see a and b, I won't just write a, I won't just write b, I'll write what a is and what b is. So my a is y prime prime over 2, so I have 1 over 2 y prime prime, then the x squared plus what is your b? Y prime minus y prime prime x. So I have y prime minus y prime prime x. Don't forget you have another x here, so I have the x here. So y equals 1 over 2 y prime prime x. I'll open the bracket, so I'll have y prime x minus y prime prime x squared. So I can have still the same thing. After opening the bracket, I should have this. Then I'll have y equals 1 over 2 y prime prime x squared. Now look at it. This is just like you saying half minus 1, because this is the same thing, y prime prime x squared, y prime prime x squared. So you have the coefficient to be half and the coefficient of this one to be 1. So that means you are saying 1 over 2 minus 1, which is minus 1 over 2. So I can have this to be minus 1 over 2 y prime prime x squared plus y prime x. And I want everything to stay in the same place, so I'll just say y. If I take this over to the other side, since it's having minus, it will turn to plus, because it is crossing the equal sign. So I have y plus 1 over 2 y prime prime x squared. Now this is plus. When it's crossed this equal sign, it turns to minus. So I have minus y prime x equals 0. So you can rearrange if you like to make sure you have your d squared y d x squared coming first. So I have 1 over 2 y prime prime x squared minus y prime x plus y equals 0. So like I said, your y prime prime is the same thing as d squared y over the x squared. So instead of writing d squared y over the x squared, you can just write y prime prime to make things easy and to make your work neat. So that's the solution. So we've formed a differential equation here. Now going to the next question, question 4. Don't forget, I said for question 4, this is a solution. So if we don't get this solution, it means there's a problem. Now we have two constants. We have to differentiate with respect to the number of constants we have. That means I have to differentiate twice. And if I don't end up having a differential equation after differentiating twice, then I'll do the same thing. I'll make sure I make those constants to stand alone and then equate it back to the question. That is one. Sometimes it might not be that you might not have to solve it that way. You can also add, subtract, but then we get there. So this, you have y prime. Once differentiates y, this is also, I'll use product rule, right? So a and e raised to minus 4x. And don't forget, I said if you have a raised to minus 4x, I bring this down, If I differentiate a, I have 0. If I differentiate this, first differentiate what you have on top. So I have minus 4x. If I differentiate minus 4x, I should have minus 4, right? So I have minus 4, and then I write my question back. Here's for minus 4x, and then I cross multiply. So I can have this to be minus 4a raised by minus 4x plus 0. That's the first one, minus 4a raised by minus 4x. Then this same one too should be minus 6b raised by minus 6x. So you do it gently, you should get the same thing. Now I'll differentiate the second time. I'll show you just one. So that means I want to differentiate this man first. So I'd have minus 4 a raised by minus 4x, right? So the constant should stand alone. Then a raised by minus 4x. I bring this down. If I differentiate this constant to turn to 0. If I differentiate this, should have minus 4 a raised by minus 4x, because when I differentiate this power, I have minus 4, right? Then I write down my question back. So if I cross multiply, minus times minus turn to plus, right? 4 times 4 is 16. Then a raised by minus 4x. That's how we have it like this. So do the same thing with this. It should be plus 36b raised by minus 6x. So I'm looking for a way to eradicate a onto or any constant. You know, when you're forming a differential equation, you are looking for a way to ensure you don't have any constant in that equation. That is what you are doing in formation of differential equation. So looking at this now, I can either, okay, now I told you have to make b and a the subject of the equation. So but for me to do that, I have to eradicate one man here. So if I look at this equation, the first equation, I have y prime equals minus 4a raised by minus 4x minus 6b raised by minus 6x. If I multiply this first equation by 4, what will happen? I will have this same thing, such that when I add both together, this will turn to 0. This is what I'm saying. If I multiply this first equation by 4, I have 4y prime equals minus 16a raised by minus 4x. Then 4 times 6 is what? Minus 24b e raised to power minus 6x. So then I will write this second equation like this. Notice that this first equation now, I have minus 16 and plus 16. So if I add, I should be able to cancel out this. So if I say minus 16 plus 16 to give me 0, so I won't have a again. But if I say minus 16 plus 16, what will it give me? Minus 16 minus 16. It will give me minus 32, right? But I want to eradicate a, so that means I have to add these two equations. So if I add, I will have y prime prime plus 4y prime equals, this will turn to 0, right? So 36 plus minus 24. So that's 36 plus minus 24. It implies 36 minus 24. So that means I'll have 12 b e raised to power minus 6x. So I told you we have to make the constant the subject of the formula. So if I'm making the constant the subject of the formula, I'll have b equals y prime prime plus 4y prime over 12 e raised to power minus 6x. So after doing this, just like we did the first time, after making a constant subject of the formula, you equate it back into the second equation. So if you look at this is our second equation here. So I'll equate b inside this equation so that I'll have to make a the subject of the formula. Then after having a and b, don't forget, we just have to impute it back into this, or we go through another process. So anyhow you want to do it, just and you definitely get the same answer. So this is y prime prime minus equals 16a e raised to power minus 4x plus 36b, but I won't write b again, right? I'll just write the value of b, and the value of b is y prime prime plus 4y prime. I have my e raised to power minus 6x back. So here I can divide. So 12 here 1, 12 here should be 3. So I have 16a e raised to power minus 4x plus 3. You know, when I have 3 here, it should be like this: 3 into brackets y prime prime plus 4y prime. So that when I open the bracket, I should have 3y prime prime plus 12y prime. You get it? So this is it. So then I can take all those y prime prime to one side and let a stand alone. So after taking this, I should have y prime prime minus 3y prime. Taking this to the other side, so I'll have minus 12y prime equals 16a e raised to power minus 4x. And I divide both sides. Notice that this is 1y prime prime minus 3y prime prime. So that is 1 minus 3, and that should be minus 2. That's why I have minus 2y prime prime. Then minus 12y prime equals 16. So to make everything easy, you can either work this way or you just simplify. So for me to simplify, notice that 2 can go in everything. So I'll divide all through by 2. So here I should have minus y prime prime minus 6y prime equals 8a e raised to power minus 4x. So then I can make a the subject of the equation. So I'll have, that means I'll divide both sides by 8 e raised to power minus 4x. Then I should have a equals minus y prime prime minus 6y prime over 8 e raised to power minus 4x. Now I already have a and I have b. What am I supposed to do? I'll put a and b into the question that is being given to me. And the question that I have is y equals a raised to power minus 4x plus b e raised to power minus 6x. So instead of writing a back and b back, I'll write the value of a and b. So the value of a is this, right? And b is this. Sorry. So y equals this. So value of a is this and b is this. So I'll just input it into this equation. So I have y equals minus y prime prime minus 6y prime over 8 plus y prime prime plus 4y prime over 12. So from here I can get the LCM. The LCM of 8 and 12 is 24. So after doing 24 divided by 8 should be 3. So, and I have 3, it means I should have 3 into bracket minus y prime prime minus 6y prime, right? Then plus 12, and 24 in 12 should give you 2. So I'll have plus 2 y prime prime plus 4 y prime, which is the same as minus 3 y prime prime minus 18 y prime plus 2 y prime prime plus 8 y prime. So that's why I have it this way. So I can just cross multiply. So I have 24y equals, so then I collect like terms. If I collect like terms, this is minus 3y prime prime. I look for another one that's having y prime prime, this one, so I marry them together. That's minus 3 plus 2. That's minus 1 y prime prime. This one too, minus 8y prime plus 8y prime. That's minus 10y prime. So that's why I have it like this. So I take all this to the other side. I have 24y plus y prime prime plus 10y prime equals 0, which is the same thing as what we have using the shortcuts. So can you see that the shortcut is so easy? With just 3 lines, we can easily get the answer to the solution. The answer to the question, excuse me. So if you want to get the video for this shortcut, which I'm going to be uploading soon, you have to kind of subscribe so that you get notified immediately I upload the video. So you see 3 lines for, I think, 1.5 page. So going to the next question, we have this. You should have this as your solution. If you don't have this, then there's a problem. So last question, we have this. Y equals e raised to power minus 2x into a plus bx. Now I can decide to open the bracket and I can decide not to open the bracket. As far as you are very smart with differentiation, you should not have problem here. But if you think you have problem with differentiation and you need me to do videos on that, you can let me know. I'll make sure I do an explanatory video on differentiation. But trust me, I'll explain this very well so you won't have any problem. So here, you open the bracket. So I have a e raised to power minus 2x, then plus bx raised to power minus 2x. Now when I differentiate this is it. You have a e raised to power minus 2x plus bx e raised to power minus 2x. I want to differentiate this. I'll use product rule, right? So I have a e raised to power minus 2x. Bring it down. Differentiate a is 0. Differentiate e raised to power minus 2x. All you have. Don't forget, I said differentiate what you have on top first. So that should be minus 2. Then write your question back. Then you cross multiply. So this times this should be minus 2a e raised to power minus 2x plus 0. That's for this first man. Go to this man too. I have b. Now this, listen to this very well, it's very important. You have bx e raised to power minus 2x. So I bring this down. Once you differentiate this, that means I have to go to one, probably a rough place, and then differentiate this by side. So I have, there's another shortcut for this though, but I think this is better than the other one, so you don't get confused when I'm doing it. So I'm differentiating this. I bring this down. I have 0, then this is 1, then I cross multiply, right? So 1 times b is b plus 0 times x is 0. That means if I differentiate this, I should have b. If I differentiate this, I should have minus 2 e raised to power minus 2x. Then I cross multiply. So I have this times this should be minus 2b minus 2. Alright, let me just do it this way. So I'll have, so we can have minus 2 e raised to power minus 2x bx after multiplying this. Then this has plus b e raised to power minus 2x. So I would like to rearrange this. So I have minus 2b e raised to power minus 2x x plus b e raised to power minus 2x. So this is it. for the second man. So that means I'll have this 2. That is why I have it to be minus 2 a e raised to power minus 2x plus b e raised to power minus 2x plus x b e raised to power minus 2x, then the minus 2. Don't forget here, it's the same thing. So just do the differentiation gently, you get it right. So here I just had to rearrange. So this, then minus 2bx e raised to power minus 2x. Then I differentiate the second time using product rule. Here I'll have 4a e raised to power minus 2x minus 2b instead, e raised to power minus 2x. So just follow the product rule and then you get the same thing. Then this is minus 2, you bring it out. Notice that we've differentiated this before, bx raised to power minus 2x, which is this, and it gave us minus 2 b e raised to power minus 2x plus b e raised to power minus 2x, which is the same thing as this. So automatically I can just use this minus 2 to open the bracket. So now that's why I have it to be y prime prime equals 4a e raised to power minus 2x minus 2b raised to power minus 2x, then minus 2, using this to open the brackets, I have minus 2b raised to power minus 2x, then minus 2 times minus 2 give you plus 4, then bx raised to power minus 2x. Now you can decide to rearrange. So I have 4 a e raised to power minus 2x minus 4b raised to power minus 2x, because this is minus 2 and minus 2, the same thing. So minus 2 give you minus 4, then 4b raised to power minus 2x. So now I have my y prime prime equals, now from this equation 2 I want to rearrange again. So I have 4 a e raised to power minus 2x. I want to take this to be beside this. So I have 4 a raised to power minus 2x plus 4bx raised to power minus 2x, then this minus 4b raised to power minus 2x, because I want to show you something important. So now I have my y prime prime because 4 is common, so I bring 4 out. I have a raised to power minus 2x plus bx raised to power minus 2x, then this minus 4 should stand alone. Notice that this man here is equivalent to the question here. So that means I can just tell you that my y prime prime equals 4y minus 4b raised to power minus 2x. So I can just collect like them. So I have y prime prime equals minus 4y equals minus 4b raised to power minus 2x. And I want this to stand alone, so I have this divided both sides by minus 4. Then I go back to equation 1, do the same thing. This is equation 1. This, the first derivative or the first differentiation. So we have this. So I notice that minus 2 is common here. So I bring minus 2 out. So this should be a e raised to power minus 2x plus b x raised to power minus 2x. Now look at it. If you open the bracket with this, you should get this back. So this should be minus 2a raised to power minus 2x minus 2b. So now notice that this is the question, right? This is y. So I have y prime equals minus 2y plus b raised to power minus 2x. Then the same thing, you collect like, okay, I take this to the other side. So I have y prime plus 2y equals b raised to power minus 2x. Now look at this. We have this to be equal to b raised to power minus 2x. I also have this to be equal to b e raised to power minus 2x. So it's the same thing as me saying, let's say I say x equals 1 plus 2y, and I have another x equals 1 plus 3y. It means x equals x, then this should be equal to this, right? So that means x equals x, go, then I'll have 1 plus 2y equals 1 plus 3y, and I can solve. So the same thing here, since I have this to be equal to b raised to power 2x, then I have this again to be equal to b raised to power minus 2x. I can automatically equate both, so I'll just have y prime prime minus 4y over minus 4 equals y prime plus 2y. Then I can cross multiply, so I have y prime prime minus 4y equals 4 into bracket this, so I'll have minus 4 into all this, So I have minus 4y prime, y prime, minus 4 times 2 is minus 8y. And I have y prime prime minus 4y. I take this to the other side. So since it is crossing the equal sign, to turn to plus. So I have plus 4y prime. This will also cross the equal sign. So I'll have plus 8y equals 0. So now this should be y prime prime minus 4y plus 8y. That's 8 minus 4. I'll have 4y. Then plus 4y prime equals 0, which is the same thing as what we have here. So just like I said, you can use the shortcut when the exam is a CBT exam, and you can also use it when you're doing a written exam to be sure of your solution. So for you to get the full video for the shortcut, make sure you subscribe and also like the video. If you really did understand what I did, so please do like the video and subscribe. Also turn on your notification bell so that you get notified immediately I upload a video on this. So don't forget, I said you have to differentiate with respect to the number of constants you have, and then after differentiating, if you notice that it doesn't form a differential equation, all you need to do is make those constants the subject of the equation and then equate it back to your question. So that is all. I hope this video really helped. So if it did, do like and subscribe. Thank you and have a nice day.